your test, this is where we left off. And what we did is we started with the synthetic division, and then we just built on the synthetic division. And so after we did the synthetic division, I showed you how to use the remainder theorem, and I also showed you how to use the factor theorem to completely factor these polynomials of the higher degree. We did third degree. Now in Algebra 1, you guys should have come in here knowing how to factor a second degree polynomial. But then what we did is we took the rational root theorem, or the factor theorem, and we kept going, and we learned how to actually solve the equations, which I told you, either one is going to say solve, two is going to say find the zeros, okay? If it says solve, that is exactly what you're doing. You will see either one of these. They mean the exact same thing, okay? So remember, I told you, and this is where we're going to start tonight, what you're going to do is you're going to write down your C, which is your constant, and write down your D, which is your leading coefficient, and you're going to list the factors of each. Then to find your possible solutions. I'm not saying that all of your solutions are going to be in this list, but to find your possible solutions, the ones that you're going to test out, you're going to put your C over your D. And so you're going to put all of your C's over D. Well, if your leading coefficient's 1, it's not that bad. So you're going to get all whole number possible solutions. And then what you do, and we did by rows to save a little bit of time, you're going to test each one of these using your synthetic division, and you're going to try to come up with a 0. So we tried 1 and -1 and 2, and obviously 2 worked. Okay? And so this is going to be your quotient after you do that synthetic division. So 2 is a solution. We already know that. But remember, I showed you how to write it as factors. And then what you're going to do from here is you can either factor this quadratic, or you can use the quadratic formula. That's completely and totally up to you. We chose to factor this, and that's fine. And then set each one of them equal to 0 and come up with your solutions. So you can see this time, and this is not always going to happen, this time all of our solutions were found in our possible solution list. But that's not always going to happen, okay? So let's look at this one. Let's try again, just kind of as a review. Our constant is going to be 4. Our leading coefficient is going to be, and then if we list all of the factors of 4, we're going to get, good, and if we list all of the factors of 3, you're just going to get 1 and 3. So now, when your leading coefficient is not 1, you're going to have some fractional possible solutions. So if we put all of our C's over all of our D's, watch what happens. These are your possible solutions. First of all, I'm going to put 1, 2, and 4 over 1 and over 1. So we're going to get plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1. And then what I'm going to do is I'm going to put my factors of 4 over 3. And this is where your fractions are going to come into play. 1 over, or plus or minus 1 over 3, plus or minus 2 over 3, and plus or minus 4 over 3. So now what I have here is I have 12 possibilities. 12 possibilities. Now I will tell you this, I will not ask you to start with fractions, okay? So when you're working your test next week, yes, you have a Chapter 9 test next week. When you're working your test next week, if you don't find one of your whole numbers to divide out to come out with a remainder of 0, you've done something wrong. Go back and check them, okay? So let's save a little bit of time and go by rows again. So what I want you to do is, you guys, I want y'all to try 1. I want y'all to do -1, 2, -2, and go ahead and go with 4. When you find one that comes up with a remainder of 0. So, -4 is going to work. So, I'll go ahead and review that for you. So, we're going to put, remember, the only time you're going to take the opposite of the number that you're going to put as your divisor is when I give you a binomial. Okay? If you're actually plugging the numbers in like this, you're not going to take the opposite. It's only when you're dividing by that binomial that's when you got to take the opposite. So we're actually going to try -4. And so underneath we're going to have 3, 8, -15, and 4. What happens if I miss an exponent? In other words, what if this had gone to 3x to the third straight to -15x? What would we put here? Don't forget that. All right. So we'll bring down this 3. -4 times 3 is going to give you a -12. 8 and -12 is going to be -4. -4 times -4 is going to be a +16. Add those together and you're going to get 1. -4 times 1 is -4 and you get a remainder of 0. So, x equals -4. We can go ahead and write that down. That is going to be a solution. So now what we have is x plus 4. When you put it back in binomial form, you have to take the opposite of it. And then you're going to have 3x squared minus 4x plus 1. So you can try to factor this if you want to. If you don't want to factor it, though, you have the quadratic formula. All right? And so we'll just go there. I think this one will factor, so if you want to factor it, you can. But I'm going to use the quadratic formula on this one. So we're going to have x is equal to, remember you have opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So a is what? Yes, here's a. What is b and c? Alright, so opposite of b is going to give me a +4. Plus or minus is where the two answers are going to come from at the end. At the very end is when you're going to use that. B squared is going to be -4 squared, and when you put that in your calculator, make sure you use parentheses, otherwise it'll give you the wrong answer. Minus 4 times a again is 3, and c is 1. All over 2 times a. So let's do some math. So underneath, we're going to have 4 plus or minus square roots. -4 squared is going to be 16. -4 times 3 times 1 is going to give me -12 all over 6. So we have 4 plus or minus the square root of 4 over 6. So we have 4 plus or minus 2 over 6. You can reduce all of those and then do the math, or you can just go ahead and start doing the math. So the top side tells me to do 4 plus 2 over 6, which is going to be 1. And then the bottom side is going to be 4 minus 2 over 6, which is going to be 1/3. So our other 3 solutions, or our other 2 solutions, are going to be 1 and 1/3. And you notice all of these solutions did actually come from our possible solution set. So when is it that these solutions are not going to come from our possible solution set? That's going to be when you get an irrational answer. When it won't factor and you have to use the quadratic formula, either 1, you're going to come up with an imaginary number, or 2, you're going to come up with a radical that won't reduce. Okay? And so we're going to work some of those. So what we're going to do is we're going to let this lead into actually graphing of these polynomial functions. Now, we're going to do 3rd degree, okay, because you already know that if you don't see any exponents whatsoever, that's going to be a straight line. If you see a squared, that's going to be a parabola. And if you see a 3rd degree, it's either up, up, and away, or it's a snake curve, an S curve, okay? So what you're going to do is you're going to put all this together. Step number 1 is you're going to find and plot the zeros. These are x coordinates. What we just found were x coordinates, and that's 1 plus the square root of 7. You can turn that into a decimal, okay? So what happens if I get a complex number like I told you earlier? What if you get an imaginary number with an I? That just means that there's not an x-intercept there. There's a dip, but we just don't quite know where it is, okay? But there's not an x-intercept. So you're going to find and plot the zeros of the curve. That's going to be your x-intercepts. And then we're going to investigate signs. We're not going to be technical about this at all. Okay? And I'm going to show you what I mean. And then select a couple of arbitrary points. I don't even care to do this. The main two things that I want you to do is, number one, be able to find the zeros, get them on the x-axis. And number two, figure out if it starts in the positive or the negative and snake it through. Okay? We'll do the rest in calculus because the rest of it's easier in calculus anyway. So, look at this. This is something that we have not seen. If you have a function that is equal to 3 binomials, like this right here. If you have a function, and I would put a star next to this one, because this problem, you can make this as easy or as hard as you want to. Anytime you see a polynomial equation and I ask you to solve it, the first thing you want to do is set it equal to 0. Well, we have a functional equation. And if I took this and I set it equal to 0, and I asked you to find the zeros, would you multiply them all out and then solve? Or would you use the zero product property and take each one and set them equal to 0? Yeah. So this problem, you don't even have to do your C over D's. This problem, if you multiply it out and then do your C over D's, I promise you you're going the long way about this. Okay? All you have to do at this point is take each factor and set it equal to 0. And solve. So you're going to get x is equal to 2, x is equal to 3, and x is equal to negative 1. You'll see one like this on your test. It's probably going to be one of the easiest problems on the test. Make sure you don't turn it into a hard problem. Okay? So, we found the zeros. We found the x-intercepts. So let's plot these on our x-axis. So we're going to have an ordered pair at 2, we're going to have an ordered pair at 3, and we're going to have an ordered pair at negative 1. From here, we are not going to be technical at all. I'm just going to show you the basic curve, what it's kind of going to sort of do, and then in calculus we'll talk about the other stuff. So what I want you to do at this point is I want you to choose a number to the left of your leftmost point. Can you do that for me? Choose a number to the left of your leftmost point. Negative 3. Okay, and this is what you're going to do. F of negative 3. Which means you're going to have negative 3 minus 2 times negative 3 minus 3 times negative 3 plus 1. Do the math. So we're going to have what? Negative 5, negative 6, and negative 2. Right? So when you multiply all these together, what are you going to get? And so do you have an ordered pair? What's the ordered pair going to be? Negative 3, negative 60. So watch this, okay? Negative 3, negative 60 is going to be an ordered pair that's going to be way down here somewhere, right? Here's your negative 3, and negative 60 is going to be way down here. The point is, I want you to know that it's coming from the negative direction. It's coming from the negative direction. So all I'm going to ask you to do is this right here. If I can draw. You're going to snake up, down, and there you go. That's all you're going to do. We're not going to find maximum and minimums because there's a thing called the derivative that will find the maximum and minimum for you. We'll talk about that in calculus, okay? What I need you to know is what the basic curve looks like. All right? What if I had to come up with a positive number for my answer right here? That just means that it would come from up here and you'd snake it through the other way. Again, we're not going to be technical about it, okay? My main thing is, can you find those zeros? All right, so what if you have a problem like this? If you have a problem like this, the first thing you're going to want to do is your C over your D's, right? So my question to you is this: what is C? There's not one. minuscule, therefore there's not 1. Therefore your C would be 0. So what's going to happen when you start making your C over D's? It's all going to be 0. So that should be cluing in your head that something's funky about this problem. What do you think? Think back to your factoring days. What's the first thing you always look for when you factor? Something in common. There's an X in common here. So if I'm asking you to find the zeros and your process is to do C over D's and there is no C, there's got to be an easier way rather than sitting there racking your brains. The easier way would be to factor out what's in common. Okay? Now, you have a choice. You can either use the quadratic formula for your x squared plus x minus 2, or you can factor it. I think this one will factor, so that's what I'm going to do. And remember, this is a functional equation, so we can set it equal to 0. And at this point, how many zeros should I expect? Why 3? It's a third degree polynomial, and you have 3 factors. So I should expect 3 answers. Well, the first one's going to be what? 0. We had already determined that a long time ago. And then the next one's going to be what? And the last one? So you're going to have 0, -2, and 1. So you found your zeros. So we've done 2 problems, 2 graphing problems that are extremely easy. And therefore, we're going to get these right. Katrina. These are not that bad. Don't shy away from the graphing, Leslie. This is not that bad. Y'all can do anything in math that I ask you to do, but I throw a graph in front of you and you start freaking out on me. Stop it. The graph is not bad at all.
This one's not, but you're going to get harder.
No, well, maybe. Okay.
You shouldn't have said that.
Tell me a number. What do you want to try? -3 again. Okay. -3. So, and again, honestly, all we've done from here to here to here is manipulated the exact same polynomial function. So you can plug that -3 into the original problem. You can plug it in here, or you can plug it in here. Whichever's easiest for you, okay? I'm just going to go back and plug it in here. So if we have -3 to the 3rd power plus -3 squared minus 2 times -3. I'm thinking we're going to get a negative number. I don't know exactly what it is. Does anybody know exactly what it is? Okay. I disagree. Because -3 cubed is going to be -27. And then -3 squared is going to be 9. And then this is going to be 6. So if I put all that together, what am I going to get? But the point is that it's a negative number, right? It's a negative number. Not a -1, just a negative number. Alright, so if I plot -3, I'm going to be at -12, which is going to be down here, way down here somewhere. So just know that, again, this thing is going to snake up, down, and back up. But again, if I had got a positive, it would have just come from this side and gone down. Okay? Always use a number to the left, because we read our graphs from the left to the right, so we're going to start graphing from the left to the right. So yeah, always choose a number to the left of your leftmost point, or your leftmost 0, I guess I should say. Okay, let's do one that's not so easy. We did this problem the other day, right? Yeah. We've already done this problem, so let's see if you can redo it. Alright, so I want you to graph this. So the first thing you got to do is you got to find your zeros. First thing you got to do is you got to find your zeros. So C is going to be -4. The negative, it really doesn't come into play, so we're just going to go ahead and write 4. D is going to be 1. And so your possible solutions are going to be 1/1, 2/1, and 4/1. And of course, it's all plus or minus. Which one worked? Do you remember? Looking back in your notes. Two. Two. Yeah, we did this one last week. All right, so 2 worked. So we're going to cheat and look back at our notes. So we have 1, 1, -4, -4. Drop the 1. 2 times 1 is 2. Add them together to get 3. 2 times 3 is 6. Add them together to get -2. -2 times -2. It's a positive 6. So 2 times 2 is going to be 4. And you're going to get 0. So we're going to have x squared plus 3x plus 2 equals 0. So one of our solutions is 2. This one factored, right? And again, if you don't want to factor, that's fine. Just know that quadratic formula. So your other solutions are -2 and -1. So we have one at -2, we have one at -1, and we have one at 2. All right, what do y'all want to try? Again? Okay.
Why not? Press.
Why not? F of -3. All right. So what are you going to get when you do this? I think it's still going to be negative, don't you? Something negative, yeah. All right, so it's still going to come from the bottom. Now, again, not all of them are going to come from the bottom, so don't assume anything. So, on your test next week, you will see graphing. You will see one like this. Don't make it harder than what it is. A little bit of studying goes a long ways. You will see one like this. Don't get confused when there's not a C. Okay, there's an easier way out. And then you will see one like this, where you actually have to find the C over D's. All right? Any questions about graphing these polynomial functions? Do you want to try another one on your own? Or are you good? You want to try another one on your own? Do this. So the last thing we're going to talk about is graphing the rational functions. And like Katrina said, I know this is going to get harder, but if you remember your transformations, your H and your K's, how things move around, these are not going to be that bad. Okay? Now, when you do a graph, and this is a little bit of the calculus part because you are in a pre-calc class. When you have a graph, if you can draw the graph without ever picking your pencil up, which is what we've done up until this point, that's called a continuous graph. So all of your linear graphs, all of your parabolas, all your up and aways, your S-curves, your square roots, your radical graphs, all of those are continuous graphs because you can't make them undefined. Remember your domain? Remember how to find those domains? You can't make any graph that we've done to this point undefined. And so therefore, there is no break in the graph at all. However, when you come to rational functions, a fraction, you can make a fraction undefined, right? How? 0 where? In the denominator. If your denominator is 0, then this graph is going to be undefined. Where a graph or where a function is undefined, there's a break in the graph, which means you're going to have to pick your pencil up. Okay? So, I'm going to show you through investigation what happens with a basic 1 over x curve, with a basic rational function. So if we do a little bit of investigation, let's do the t-chart. And let's come up with a bunch of ordered pairs. Okay? Obviously, which one can you not use? Because think of your domain. X cannot be what? X cannot be 0, so just stay away from it, okay? But let's go to the right and to the left of it, okay? If we go to the right or left, let's use 1, -1, 2, and -2. That's a great place to start. All right, so 1 over 1, of course, is 1. 1 over -1 is -1. 1 over 2 is 1/2, and 1 over -2 is -1/2. But I want to see what happens when I get closer to 0. So let's try this. Let's try plugging in 1/2 and -1/2. Get closer to 0. So if I plug in 1/2 for x, do you remember how to do that? Do you remember how to do a complex fraction? 1 over 1/2. Yes. Basically, you're going to get 2. Right? And if I plug a -1/2 in, I'm going to get a -2. So let's plot these and see what happens. 1, 1 is going to go here. -1, -1 is going to go here. If I go to 2, it's going to be at 1/2, and if I go to -2, it's going to be at -1/2. But if I go to 1/2, it's going to go up to 2, and if I go to -1/2, it's going to go down to 2. Do you see what this curve is doing? What we have here are 2 asymptotes. When you have a function that can be undefined, what happens is you make asymptotes. Asymptotes are imaginary lines that your graph cannot touch. Instead, the closer your graph gets to the asymptote, the more the graph is going to bend. So, what we have here is 2 parabolas. Your asymptotes are your y-axis and your x-axis. So these graphs will never touch either of the asymptotes. Neither one of them. Neither your x nor your y. So this is your basic 1 over x curve. Now, some things that I want you to know about this basic 1 over x curve, this basic rational function curve. You notice that you have a parabola in quadrant 1 and quadrant 3. Okay? As long as your rational function is positive, that's going to happen. As long as your rational function is positive, you will have a parabola in 1 and 3. 1 and 3. But if I did this, it's going to be 2 and 4. Okay? If I made that rational function negative, it'd be 2 and 4. Alright? So this is what I'm going to ask you to do. I'm going to ask you to, number 1, find the asymptotes, okay? And again, I already told you asymptotes is an imaginary line where a function cannot be defined. So, your vertical asymptote is the value of x that makes the function undefined. In other words, to find your vertical asymptote, which way is vertical? This way is vertical, okay? To find your vertical asymptote, what you're going to do is you're going to find your domain. Basically, take your denominator and set it equal to 0. That's going to be your vertical asymptote. So I have a vertical asymptote for this one. I have a vertical asymptote at x equal 0. Vertical asymptote is a line. It's imaginary, but it is a line. Okay? And so we'll write it as a line. X equals 0 is a vertical line going through the x-axis at 0. So to find your vertical asymptote, you take your denominator and set it equal to 0. Now, to find the horizontal asymptote is the value of f of x or y. It must have a variable in the numerator. Underline this, highlight it, whatever. If you do not have a variable in the numerator. If you do not have a variable in the numerator, your horizontal asymptote is y equals 0. Okay? Must have a variable in the numerator. If not, your horizontal asymptote is y equals 0. If you have a variable in the numerator, if you do have a variable in the numerator, and getting into a little bit of calculus here, your degrees of your numerator and denominator are the same, then it's going to be leading coefficient over leading coefficient. And I'll show you one like that in just a minute, okay? So asymptotes will cause a continuous function to become discontinuous. We've already talked about that. For rational functions, a vertical asymptote, we just said that, can be found by setting the denominator equal to 0. For rational functions, your horizontal asymptote, here it is. Your horizontal asymptote can be found by dividing leading coefficient of the numerator by leading coefficient of the denominator, if you have the same degree. If you have the same degree. But you have to have a variable in the numerator. Okay, if not, it's just automatically 0. Yes?
You said if you do not have a variable in the numerator, you're going to have a y asymptote.
0. Okay, so let's look at this. To graph this, the first thing I want you to do is I want you to find the vertical asymptote and the horizontal asymptote. How do you find the vertical asymptote? Take your denominator and set it equal to 0. So I have a vertical asymptote at 2. Do you see what it did to my graph? It shifted it to the right too. That sounds a lot like what? An H. That's a vertical shift to the right. So that is going to be your H. Very good. No. Yes. All right, so your horizontal asymptote. So for your horizontal asymptote, what do you think it's going to be? It's going to be y equals something. Why is it 0? There is no variable in the numerator. Very good. Since there's no variable in the numerator, your horizontal asymptote is 0. So all we've done is shifted this to the right. It's a horizontal shift. It is an H to the right too. And I know that because, look, I told you a long time ago that H always goes with what? H always goes with S. There it is. And you've always got to take the opposite of H, right? There it is. So now, this is the easy part, okay? Because again, we're not going to get very technical about this. Is this rational function positive or negative? Positive. So what quadrants do you think it's going to be in? But do you see your new 1 and 3 quadrant? This is your new quadrant 1, and this is your new quadrant 3. So, again, the 3 makes it a little more wide, but we're just not going to worry about that. As long as you get your asymptotes and the right quadrants, I'm going to be happy. That's horrible. So you have 2 parabolas. One's in quadrant 1 in your new quadrant 1, and one's in quadrant 3. Again, your new quadrant 3. Leading coefficient over leading coefficient. So it would be y equals 3. 3 over 1. Right? Leading coefficient over leading coefficient. If this whole function is positive. The only way I would change that is if I did that right there. If I made it negative. Anything else? Now, if all else fails, you have options, right? Back in Math 100, no matter who you had, every one of us told you that if you come across a graph and you don't know how to graph it, what can you always fall back on? Wow. T-chart. If you see something and you don't know what it graphs, do a T-chart. And then hopefully you'll be like, oh yeah, I remember that. Hopefully. If not, yeah, exactly. Okay, so look at this one. What do you think a negative 2 is? Yeah, that's going to be a K. That's going to be a vertical shift. That's going to be a vertical shift. All right, but let's do this. You have your vertical asymptote and your horizontal asymptote. And I don't want you to overthink this, but I'm just gonna show you this, okay? Don't panic. What I'm gonna do is I'm gonna make this into one fraction, 1 over x minus 2. We need a common denominator of x, right? So you have 1 minus 2x over x. But if I put it in descending order, that's the exact same fraction. This is the exact same thing as this. Now, if you can look at this and see that that's a K, all right, because it's a number out there by itself. There's nothing down here with x. If you can look at that, you know that that's going to be a vertical shift. If not, look here. How do I find the vertical asymptote? Denominator equals 0. So there's your vertical asymptote. So there is no left to right shift. There's no H, so there's no left to right shift. To find your horizontal asymptote, what did I tell you? Go off of this one. If there's a variable in the numerator. There is a variable in the numerator.
So it's negative 2.
So you have negative 2 over 1, which is negative 2. So you have y equals negative 2. So you can either do this, or you can know that that is an H and do this. Either way. So we do have a vertical asymptote here. It's just your y-axis. And then you have a horizontal asymptote at negative 2, which is here. Now, let's play around with this, because look, up here, I have a positive fraction, and down here, I have a negative fraction. So we need to figure out, is this going to be in quadrant 1 and 3, or is it going to be in quadrant 2 and 4? You do a T-chart and figure it out. What happens if you plug in 1? That's a good indicator. What happens if you plug in 1? You're going to get a negative 1. What happens if you plug in negative 1? You're going to get a negative 3. And that, just those 2 points right there tells you which quadrant you're going to be in. Those 2 points right there will tell you which quadrant you're going to be in. But again, it shifted, okay? I totally didn't hit those points, but that's okay. But it did shift down to. Questions? So we've seen a vertical shift and we've seen a horizontal shift, right? Okay, so what happens if you square the bottom? What happens if you square the bottom? If you square a negative number, what happens? You get a positive. Negative 2 times negative 2 is positive 4. So every time I plug in a negative x value, what kind of y value am I going to get? Positive. So this square down here is going to put me in quadrant 1 and 2. Quadrant 1 and 2. So this is another basic curve that you need to know. It's just another basic curve that you do need to know. Again, you can do vertical asymptote and horizontal asymptote if you want to. Vertical asymptote, take x squared set it equal to 0, and of course you know x is equal to 0. Horizontal asymptote is automatically 0 because we don't have a variable in the numerator.
So no change to
So there's no shift whatsoever. But if you play around with the T-chart, it's going to tell you which quadrant you're going to be in. So if I plug in 1, I'm going to get 1. But if I plug in negative 1, I'm going to get 1 again. So we're here and here. So again, that's just another basic curve that you need to know. Okay, so let's look at this one. Vertical asymptote and horizontal asymptote. Vertical asymptote, take x plus 4, set it equal to 0, and you're going to get x is equal to negative 4.
and the HA is 0.
Nope,
Oh, wait. Looks up and-
it's going to be 1. You have a variable in the numerator. The degrees are the same. You have a first degree on top and a first degree on bottom, so it's leading coefficient over leading coefficient. So your y is going to be 1 over 1, which is just going to be 1. So this time we have a vertical shift and a horizontal shift. So x equals negative 4 is going to be your horizontal shift. And y equals 1 is going to be your vertical shift. So now let's go back to the T-chart and see where we're going to be. Let's plug in negative 3. If I plug in negative 3, what am I going to get? You're going to get negative 3. What if I plug in a negative 5? What quadrant are we in? 2 and 4. Now the fact that we shifted throws things off. So again, it's always a good idea to check that T-chart. Make sure you know what quadrant you're in based on the T-chart. Alright, let's try this one. What's the vertical asymptote going to be? And the horizontal asymptote? Alright, so we're going to have x is negative 2 and y is negative 3. Now if you don't know how to graph a vertical and horizontal line, that is in chapter 7 of your book. And your Math 100 teacher did not do a very good job. Alright, let's go to the T-chart. See what happens. What if we plug in 0? That's an easy one. What are we going to get? I'm thinking, well, which is 0, right? What happens if I plug in a -3? I'm thinking -9. -3 times -3 is +9. And then -3 plus 1 is going to be -1. So you're getting -9. Alright, so we're down here. So a little bit of investigation never hurt anybody. Okay. Last one we're going to talk about is this. So, again, let's look at the vertical asymptote. To find the vertical asymptote, what do? You set each one of them, or you set this equal to 0, and you solve. But if we solve, you have one of two options. How do you want to solve this? I don't care. You want to add 9 or you want to factor it? Okay, so if we add 9 to both sides, we're going to have x squared is equal to 9. Then what? How do you get rid of a square? Square root. And so we're going to have x is equal to what? Plus or minus 3. Remember, when you initiate the square root, you got to do plus or minus. So now we have two vertical asymptotes. We have two vertical asymptotes. We have one at -3 and one at +3. Horizontal asymptote, what do you think? Yeah. Look in your books on page 512. And I want you to look at examples 3 and 4. If you look at examples 3 and 4, can you tell me what the difference is? There's two differences. In example 3, what do you have? What are you looking at? First of all, can you find a vertical asymptote for example number 3? What would the vertical asymptote be for example number 3 on page 512? No. Example 3. What do you think? You would have a negative under the square root. That's not possible. Therefore, you don't have a vertical asymptote. You don't have a vertical asymptote, which means this is going to be a continuous function, but it's going to do something a little crazy. Well, if you look at the graph, you can see what it's doing. But you do have a horizontal asymptote. Why? You have a variable in the numerator. The degrees are the same, right? You have a second degree on top and a second degree on bottom. So it's leading coefficient over leading coefficient, which is going to be 2 over 1. And so that's why you see that dashed line drawn through at y equals 2. Okay, look at example number 4, which is like the one that we have on the board. Here you are going to be able to take the square root, and it's going to be plus or minus 2. And so you see those two vertical asymptotes. When you have, and it's like I said at the very beginning, when you have a vertical asymptote, it makes your graph discontinuous. You will have to pick your pencil up. And that's why in all of these we had to pick our pencil up. because we had vertical asymptotes in every single one of them. If you don't have a vertical asymptote, you're not going to have to pick your pencil, and it's going to be continuous. Example 3 is a prime example of that. You don't have a vertical asymptote, therefore, you don't have a discontinuous graph. You have a continuous graph. But in example 4, that's not the case. There is a vertical asymptote, and therefore, you are going to have to pick your pencil up. It's discontinuous. So, in this problem, in particular, we need to do some investigation. All right? We have 6 options that we can draw this graph in. We have 1, 2, 3, 4, 5, 6. We have 6 options. Okay? So, T-chart is what I say do. Just work on the T-chart. And let's pick a point in each one. Well, let's pick a point in the 3 regions that our vertical asymptote goes to, okay? So let's go to the far left region. Let's choose something like, I don't know, -4. If I plug in -4 here, what am I going to get? Do what? 3/7? Yeah, 3/7. Let's change that to a decimal. Do 3 divided by 7 in your calculator and tell me what you get. That's good. 0.42. All right, so we have -4 and 0.42. That's, I'm totally guesstimating right there. All right, so let's plug in 0. If we plug in 0, what are we going to get? Right, which is going to give me a decimal. That's easier to graph, I guess.
-1.3.
All right, and let's plug in 4. What are you going to get? I'm thinking you're going to get 0.42 back, right? So do you see some symmetry going on? Do you see some symmetry? Look, if I plug in -4, which is in this region, it's going to give me 0.42. And if I plug in a +4, which is in this region, I get the exact same value, 0.42. So it's going to be symmetrical that way. So you're going to have your parabola here and here. And then if I plug in 0, and I get a -0.3, so we're going to be down here. So you're going to have another parabola. Ooh. Kind of, sort of. Going this way. So again, that's what those asymptotes do. That's their job. You cannot go across an asymptote. So if you have an asymptote, what it's going to do, and we read these graphs from left to right, okay? And you can do some more investigation if you want to. If you wanted to plug in -10 and see what happens, you're going to come in from the left and you're going to go this way. But the closer it gets to this vertical asymptote, it's going to bend this graph straight to positive infinity. And then what's going to happen if you wanted to go back in and plug in something like -2, you'll learn that there's going to be a number way down here, and it's going to come up from this vertical asymptote, and it's going to reach that horizontal asymptote, and it's going to bend it back towards the next vertical asymptote, but it's going to bend it back down. That's what those asymptotes do. It bends the graph. Then if you go back and you plug in something like 4, which we did, it's going to come up from the top, and it's going to come down, and it's going to bend going this way. Okay? So just remember, that's the job of the asymptotes, to bend those graphs. All right. So for your test next week, for your Chapter 9 test next week, if you want to work on a study guide, you can. I think these pages are actually right. Yes, they are. Page 528, you have the numbers, and then page 529, which is the Chapter 9 practice test. It's not the actual test, it's just a practice test. You can work on those numbers as well. The numbers that I told you to put a star next to, Those are the numbers. You may not see them in here, but we went over them in class. That's fair game for the test, okay? And then, of course, these problems are definitely fair game for the